are the active devices, and that is going to be the transistor. What is the difference between transistor and diode? Diode is one junction diode. That means the junction between p-type material and n-type material, there is only one junction is going to exist. But in a transistor is a bipolar transistor. That means there will be two junctions. Either NPN transistor is there or PNP transistor is there. That means between two n-type material, there is a p-type material is going to be inserted, and that way there are two junctions are going to be prepared between the base emitter junctions. There is a one junction is there between the base to collector. There is another junction is going to be there, and that way you have to test. You have to consider this transistor is nothing but two diodes. There are two diodes, and you are measuring. You are testing two different diodes between base to emitter. There is one diode is exist, and you verify with that diodes with the forward bias resistance as well as reverse bias resistance. And similarly, between the base to collector, there is another diode. Again, you verify forward bias resistance and reverse bias resistance, and you can find out whether the transistor is working okay or not. If both the junctions are okay, then and then only that the transistor is okay, that you can conclude. Okay, in a transistor, there is a nomenclature is there. You can see that the first transistor is shown here, AC127. What is the meaning of these words A and C? A stand for silicon type of the, A stand for germanium type of the transistor, and the first letter, if it is a B, here it is shown BC548. B stand for silicon type of the transistor. Second letter shows the applications of the frequency, over which frequency range it is working. Here it is C is there. C indicates it is working or operating this transistor over a audio frequency range. That means 20 Hz to 20 kHz or something. So that way you can understand the transistor is named, and that way over which transistor, which application you want to utilize which transistor, you have to select proper transistor. Second thing, here it is SL100 transistor, SK100 transistor. What is the meaning of this SL and SK100 transistor? These are the power transistor. That means its current capacity is going to be very large. 1 ampere current capacity is there. SL100 is an NPN transistor, SK100 is a PNP transistor. Similarly, BC108, BC177, etc. transistors are going to be there. BC108 is a high frequency transistor is there, but it is a silicon transistor is there. And voltage amplifier, we normally utilize BC108. BF194. BF194, second letter is a frequency F. That means it is operating with radio frequency. For a very high frequency, you want to operate with a megahertz or something, BF194, BF195, etc. transistor is to be utilized. You can see that this transistor are BF194, BF195. This is the transistor, and there are three terminals: base, emitter, and collector will be there. Then there are different type of transistor is also available. There is a photo transistor. Photo transistor means what? Photons is going to be incident on a base, and that's why HF energy is going to be incident on that one, and the base current is going to be due to number of photons, and that way the collector current is going to be start. So that is called photo transistor will be there. There is a UJT is also there. 2N2646 is a UJT. UJT means uni-junction transistor. So there is a between a P and N type material, there is only one junction is there. So that is called UJT, which is mainly utilized to produce a relaxation oscillator. Then there is a BFW10 FET. FET means field effect transistor, and BFW10 indicates that it is having approximately gain of 10 is there. And this is SCR, silicon control rectifier. Then this is going to be tetride. This is going to be the diode, and N channel MOSFET, P channel MOSFET. This is also transistor 2N3055, but this transistor, its current capacity is going to be 15 amperes, and that's why the size of the transistor, you can see that it is bigger. And the body itself is acting like a collector. So the current handling capacity is going to be very, very high. So that way this transistor are going to be utilized. This diode, triac, etc. they comes into the thermistor family that you might have studied or you will study in future. So I'll show you one of the transistor that how I'll test the one of the transistor. First of all, this is SL100 transistor. I'm going to concentrate on SL100 transistor. It is NPN transistor. So if it is NPN transistor, there is a emitter, base and collector. Base will be middle. One of the side is going to be emitter, another side is going to be collector. So base, because it is an NPN transistor, base is a p-type material, and with the p-type material I am going to place a positive terminal of the battery of the meter, and negative terminal I am going to put it on one of the side, either it is emitter or collector, and I will be measuring the resistance. Here it shows that resistance is very, very large. So here between these two, maybe the transistor is not working. So in both the directions, in a forward bias as well as in a reverse bias, it shows infinite resistance. In the meter you can see that 0L is shown. What it indicates? Infinite resistance. That means that junction is open and that transistor is not conducting or it is not working. So that transistor you cannot utilize. So that way you can give the conclusions. You can see other transistor. This is DC 108. You can see the voltage also actually between the base emitter. There is a voltage drop across the base emitter also you can see in the meter. Put into diode range. Connections. So it is a diode range. You can say here it shows the diode also, and there is a voltage drop across the diode is 0.68 volt is there. That means in a forward bias the diode is working. Another diode, how much voltage is there between the base to collector? It is also 0.66 voltage, and that means this transistor is working properly. You can measure the resistance also, you can measure the voltage also between the base to emitter junctions, between the base to collector junctions, and in a forward bias it will show the voltage drop. If it comes around 0.6 volt for the silicon transistor and 0.3 volt across the germanium transistor, then that transistor is working. So this way you can measure the different transistors also. Thank you very much, friends. So this is the way you have to do the active components between the diode and transistor, FET, etc. Because you are not studying right now, but just see the glimpse that how the FET, etc. is also looking. You see that this is going to be the FET, this is going to be the MOSFET, etc. This you can visualize them, but the detailed study you will study in theory, and then after it is better you can study this thing. Okay, bye friends.